Someone else
record.
joined. Oh, Maya.
Okay. Okay, Maya. So we were just covering these sets. Let me see. Here. Okay. Do you know the real numbers?
Yeah, I'm just doing vocab because I always forget like what it is, but everything else kind of makes sense.
Okay, so R is real numbers. Q are the rational numbers. Numbers you can write as a fraction, 7 over 3, 10 over 2, 5 over 9. Those are all rational. The integers,
Okay.
whole numbers, and their opposites, so -1, -2, 1, 2, 4, 5, 6, 7. And natural numbers are numbers you can count on your fingers, if you had a lot of fingers. Okay, so pi. We said that pi is a real number. Is pi a rational number?
No, you can get close with a quotient, but you
No.
can't have pi.
Yeah, so that was kind of a
So
trick
what
question
is?
because, sorry?
I was gonna say like rational numbers are the ones where like the number can like represent it like with a quotient and like two integers, right?
Yes, exactly. So
Okay.
if you want to make the argument that pi over 1 is a fraction, this doesn't make sense because pi is not an integer, so it's not a normal number. So it is not a rational number. Okay.
So then, therefore, it's not an integer or natural. It's only a real number.
Yep, it's only a real number. So because integers, it's not a whole number for the negative version. It's also not a natural number because you can't put it on your fingers. That'd be weird. Okay. And now -2. Is -2 a real number? Can you graph this?
Yeah.
All right.
Yes.
Let's draw this line. How about is -2 rational?
Yes.
Yeah, you can write it as -2 over 1, -4 over 2.
Yep. Okay. And what about integer? Is -2 an integer?
Yep.
Yes.
It's an opposite of a whole number.
All right. Just make sure I'm recording. Okay. Yes. And now about natural number.
Yes.
No, you can't. You don't count -2, but you count.
Yeah, you can't count it on your fingers. That was
Wait. Oh, okay. So
all right.
because I thought like when you meant by fingers, you can still count like the neck. Okay, I got you.
So it's basically all positive. Naturals is all positive whole numbers except for 0.
Mhm.
All right.
Doesn't
Can like
natural have
0.
Oh, sorry, Maya. What were you saying?
doesn't natural have 0?
That's debated between
Apparently
mathematicians.
not.
Some
Miss
say
Frisbee
it
told us
does.
she said n has 0, but the z plus or whatever has only 1. Like those are like tiny numbers.
Right. So yeah, I don't think she would put that on the test since this is like controversial if it has 0. Because could you count 0 technically if there's nothing? So how it
Yeah.
works? It includes zeros.
She said,
Adrian.
I think for the context of the test, she's not gonna have us like she's gonna have 0 as part of natural numbers because that's what she put in her notes for us.
Okay, yeah, I'll include it here.
Adrian.
Yeah.
Would a 0.5 count as a natural number?
No, because you can't count it.
Do you count 1/2 on your fingers?
I mean, never mind.
I mean, you can cut your finger in half.
I mean, you
Like
can,
if you got like
but
half, like
now it's
little
too
joints.
technical. Now it's too technical.
Yeah.
Okay. Using the vocabulary of equation, inequality, expression, relation, identity, and or formula, classify the following. E equals mc squared. We're just going to go through them one by one. Is this an equation?
Yeah.
Yeah.
There's an equal sign, so we can leave that there. Is it an inequality?
No.
No.
Okay, and you can immediately cross it off if it is an equation. So, okay, now expression. Is there no equal sign? Okay, it's not an expression. A relation, this is a weird one.
I would say.
Sorry, what were you going to say?
No, go ahead.
Okay, so a relation, it just connects two numbers or connects quantities. So it is a relation in this case because it creates a relationship between E and M and C. So we're going to say it is a relation. Identity? An identity
No.
means that in this case, it's kind of weird in physics contests. So identity means it's always going to be true no matter what you plug in. So in this case, it is an identity because this works every time in physics. But I don't think, like, these two are kind of tricky. I don't think she would put it on the test. Okay, now finally, and or formula. Is this a formula?
Yes.
Yeah.
Okay, good. Now on to this one. Is this an equation? 19 plus x squared equals 6y.
Yeah.
Yep.
Yeah.
Yeah.
Yeah, it's an equal sign.
Is it
Yeah.
an inequality?
No.
No.
Is it an expression?
Yeah.
Yes.
No. I don't know.
No.
No.
Expressions
It has the equal sign.
they lack an equal sign. So like if you put 6 plus
Ah,
9,
okay.
that's an expression. Okay.
Wait. Can you go back? Okay, so if it's without an equal sign, it's an expression.
And like if there's nothing
Alright,
next to it, it's just this thing floating. Okay.
alright.
Relation. I guess you could argue yes, because it does create a relationship between x and y. So I'm gonna say it is. Identity. No, this is not identity because
No.
let's say x is equal to 1. That's gonna be 20 is equal to, let's just say y is 0. 20 equals 0. That's not true. So it can't be an identity because there's ways to make it false. Okay, now finally.
Yo, Agent, I got a question.
Yeah.
So the expression vocab, it wasn't on the vocab list for the one that Frisbee gave. Is this just something that you add, or is this something that she talked in class that wasn't on the list?
I added it, but she talked about it in class, I'm pretty sure, and I think she would expect us to know it.
Okay.
Yeah.
So note that down. Hold on. Alright, thank you.
Alright, welcome. So now, next one. Is this an equation? 1 plus 1 equals 2.
Yeah, because it has equal sign.
Yes.
Is it an inequality?
No.
No.
Nope. Is it an expression?
Nope.
Nope.
No.
Is it a relation? The
Yeah.
answer is
Yeah.
No, you're not relating any variables to each other.
Okay.
I see where you're coming from. If you could say it's creating a relationship between 1 and 2, but it has to be variables. Okay. Now, identity. Is this an identity?
Yeah, it's always wait.
Yep, it's always true no matter what.
Yeah, it's always true.
Identity, and now and or formula.
No, it doesn't. It's not an equality with multiple variables.
Okay. So, like not a formula, it has to have multiple variables. So this is not a formula. Okay, now the last one about vocabulary. Is 1 plus 1 equals 3 an equation?
Yeah.
Yep.
Yeah, it's just false.
All right, then you guys got this one. Yeah, it's actually not an identity either.
Wait
Sorry?
Can you give me an example of relation and identity?
Relation identity.
X equals X.
Hold up.
Oh, that's a good question. Of an repeat again.
Can you give me an example of a relation and an identity?
Okay. Here. 5x plus y is equal to 5x plus 5y. That's one example.
So relation is like both sides have an x and a y, and the other side also has an x and a y.
So relation just connects variables.
Okay.
Alright. And identity is always true. Okay. Now for the last one. Would a circle graphed be classified as a function? Why or why not?
No, because it fails the vertical line test.
Yeah, like Melvin said, we could actually write infinitely many lines that it fails the line test. So no. This is definitely not a function.
Any point on the circle has an intersection at least twice, except for the edge.
All right. Okay, we're done with classification. Let's tell them that we're moving on to
Yay!
Okay.
Whoa.
Moving on to
John Isaac.
Okay. John Isaac here. Okay.
Yes.
For this one, we're gonna need point slope form. Do you guys know point slope form?
Maybe.
Yep,
Alright.
I got it.
Is that like the y1 minus
Y-
y1
minus y1
equals like equals like that m and then square root of x, well something, I don't know, whatever.
Y minus
Okay,
y1
All right, so
That was
y
like a
minus
square
y.
root, right?
If you guys don't
Equals
know, just
m.
write it down and try to get it reeled in. Okay, is equal to
Hold
m.
up, man. Can one person talk?
Yeah, m. Oh, it was in parentheses. Oh, I thought it was square root. Alright.
Okay, I just remember because we have a y minus y1, and we do the same kind of thing with x.
Alright.
Okay, so let's see.
Wait,
For the
what are we
line,
doing now?
we're doing forms of lines.
Okay.
So let me get this out of view.
Shit, you didn't know this.
Yeah, I do need those. Or else
If you looked at Miss Frisbee's review,
I will
there's
look
a
at
lot.
that later.
There's a lot on Miss Frisbee's review about like how to convert between forms of lines.
I will look at that later.
Okay, let me erase these real quick.
That seems like a 2 a.m. me problem. Not gonna
Okay,
This is
so
not
find the
real.
equation of this line.
lie.
So what point slope does, if we have a point and a slope, as given in the name, we can find the form of the line. Okay, so if we have, let's just say this is our point. Let's plug that in. 1, comma 2 is one of the points on this line. So we're going to have y minus what? What is y1?
Huh?
-2.
Oh, mine. Yeah. I
Minus
cannot see.
Okay, we're going to do the slope later. We're just going to leave it as m for now. Times x minus what?
Is that 1?
Yep.
1.
X minus 1. Okay, and now let's find the slope between these 2 points. It's change in y divided by change in x. So we go up 2, and we go to the right 2, right?
So it's just 1.
Yep, the slope here is just 1. Okay, so now we plug in 1 for m. So y
So
minus
just
2.
subtract for slope. Just subtract the 2, like the second x and the first x to like the. Okay, I see. So
Yeah,
just
that's the
3.
same
You
thing
did
as
3 minus 1, and then 4 minus 2, right?
it's the slope formula.
Wait, that's what m equals? Slope?
And the slope.
Yeah.
Alright.
Okay, y equals mx plus b. Okay. So here y is equal to x plus 1. Let's check out if it works real quick. Okay, so 1 plus 1 is 2, 3 plus 1 is 4. So we got this one down. Okay, we're going to keep the slope-intercept form here. Sorry, slope form. And let's go on to the next one. A line passes through point 1, point 2, and point 2, point 3. Find the equation of this line. So notice here, we're not actually given any numbers. She wants us to find the formula of a line that passes through these 2 points. We can actually just use point slope again. Okay? So
Oh, so the answer to that would just be point slope form?
just pretend these are numbers and plug them in. So
Okay,
we already
I got
have y1 and x1 here plugged in. We already have them plugged in. So now we just have to solve for m. So y is equal to y minus y1 is equal to the slope. What's the slope between these 2 points?
y2 minus y1 over x2 minus x1.
Yep, change in y divided by change in x. x2 minus x1 times x minus x1. And here I would just leave like this. Boom. This is the formula for a line that passes through 2 points. Okay, so we got that one down. Let's do 2.3 now. Okay, 2.3. Find the slope of the line parallel to 4x plus 5y is equal to 7. Okay? Okay, so how do we easily tell slope? We can easily tell slope if it's something like y is equal to 5x plus 4, right? Because then we can see the slope is just 5,
slope would be
right?
4 in that, right?
The slope will be 5. In this case,
Okay.
we have a slightly funky form, so we need to change it into this form. the slope-intercept form, because here it's easy to tell what the slope is. So let's do that. We're going to isolate y, just like we see here. Okay, so we're going to have 5y is equal to 7 minus 4x. I just subtracted 4x from both sides. So cancel minus 4x. Okay. And now we divide both sides by 5. Y is equal to 7/5 minus 4x divided by 5.
So the slope would be -4/5.
Yep. So what Yagnik did is move it here plus 7/5. So that it matches the form of y is equal to mx plus b. Nice. Okay, so the slope is just -4/5. Because that's m here. Okay. We're going to do this one more time, but with a general form.
What's the other formula? What's the formula for point slope form again? Because I just have the slope intercept and I haven't memorized it. It's y1 minus y2.
Y subtracted by y1 equals the slope, which is m parentheses x. I'm not sure. Let's look at it. Never mind.
Okay.
Okay. So let's go on to find the slope of the line parallel to ax plus by equals c. And if you do A team, you want to know this one because they ask us a lot, and it's just a formula you have to know. And if you don't know the formula, just follow the steps. Okay. So we got ax plus by is equal to c. Okay, we're just going to put y by itself again. So we have by is equal to c minus ax. And then what do we do?
Divide b from both sides.
Exactly. So y is equal to c divided by b minus a divided by b.
X.
Okay, and we can rearrange. Y is equal
The
to
slope would be
negative a over b plus c over b. Okay,
you
so
forgot
now
the x.
x. Oh, you're right. Right. Sorry. Okay, so this is our slope, negative a over b. So now I know if they're an A team and they ask you, what's the slope of the line 5x plus 4 equals 3, you just do negative a over b, and that's your answer. Okay, and now let's find the slope of the line perpendicular to ax plus by equals c. We can actually just recycle this answer and make
Wouldn't
it
it be
perpendicular.
b over a?
Yep, exactly. B over a. And Maya, how did we get to b over a?
You just do the negative reciprocal.
Exactly. So she took the opposite sign, so negative, and then she switched their places. This a goes in the bottom, and this b goes in the top now.
And that would be the inverse of that?
Sorry, this is the
Wait,
reciprocal.
Adrian.
Yeah, John, Isaac?
Wait, sorry, I didn't hear because I was doing something. But for like determining if trying to find the parallel line, you just keep the slope, right? But you just change b, right? Okay,
It's
I
the
was
same
just wondering.
solve.
All right, thank you.
Okay,
And that would be the inverse, right?
this is the perpendicular line.
Wait, what? No.
This is just the perpendicular line.
That's when you want to find a line perpendicular to another line. It's nothing about inverses right now.
I think what Yagnik is referring to is, I think Connor said something like this. Perpendicular lines are inverses. Is this true?
Not always.
Yep, like Maya said, this is not always true. I think that's what Yagnik was referring to. Okay. So we got the slope of the line perpendicular to this. We got all these down. Now we're going to go on to geometry.
Ooh.
Okay. Okay. Find the area of an equilateral triangle with a side length of 5. Okay, let me draw that out real quick. So we got 5. Right. Okay, 5, 5, and 5. There is multiple ways to solve this problem. I'll go with the one I think is easiest to remember. Okay. So what we can do first is split this triangle in half. What'd you say?
Do you ever do the 30, 60, 90 thing with this one? Or do you just like do it? I mean, it's the same thing, but like.
Yeah, they're both all
I do 30,
the
60, 90.
It's whatever you prefer. So what I would do, I would split this in half. You don't have to if you don't want to. Okay, split it in half. Okay, and this becomes
What's good, Tej?
2.5. Well, that's it. This becomes 2.5. Okay, so we're just covering this problem, which is find the area of an equilateral with a side length of 5. So what I covered first is when you split it in half, and we get 2 right triangles. Okay.
So then,
So we want to find the height of this triangle, because then we could use the base times height divided by 2 formula. It's easy. So we could find the height of this.
Adrian,
Yeah.
could you use a squared plus b squared equals c squared in this case?
Yes.
No.
Or you could use the sneakier method, which is 30, 60, 90 triangle. But let's assume you don't know that or don't remember it. So you would
Yeah, I don't know what that is.
2.5 squared plus h squared is equal to 5 squared, which is 25. 2.5 squared, that's 6.25 if I'm not mistaken. Okay. Plus h squared equal to 25. Let me get a calculator out real quick.
Is this for the calculator or no calculator section?
This is for the no graphing calculator section, so just pretend I have a graphing calculator. I just
Wait.
Oh, so
She's
we can
gonna
use
let
the
us use
normal
a
one?
regular.
I think she lets us use a regular one, but
Yeah, I'd
okay.
assume so.
Yes!
She'd probably allow us. I don't understand why she.
Okay. Because she never specified for us. We didn't have her since we had her 4th period.
Yeah, we didn't ask, but I mean, like Heiser last year let us use a TI, like a TI on a
Like
regular
with the
test.
what is it called, with like cast turned off or something?
Her graphing calculators have cast turned off. You're not allowed to use those.
Test to press.
Press the test mode. Yep.
Okay, I'm trying to find
Tomorrow's
this
section.
information right now.
Tomorrow's nothing, right?
Tomorrow's no calculator.
I'm going in raw.
Not if you're here.
Let's see if she says anything about this.
You're right.
Oh, okay. It says part 1 is not allowed.
Okay.
Alright, guys. So no calculator. But in that case, she would probably give a problem that would make this like a nice answer. It wouldn't be a decimal. She'd give whole numbers. Okay, so 6.25 plus h squared is equal to 25 into x squared. Okay, so that's 4.3. So our height is 4.3. Close this out now. Okay, and now that we know our height and our base, our height is 4.3 and our base is 2.5. We just do base times height divided by 2 now.
Did they tell you guys about the format of the test?
Wouldn't you have to multiply by 5 because that's the whole base of the equilateral?
I was going to multiply this by 2 to get to like
okay.
section.
Yeah, because you would have to divide by 2 at the end anyways.
Yeah.
Sure. Both are valid methods.
So what happened?
Okay. If you guys prefer.
Did she tell you guys about the format of the test?
the format?
Nope.
Not really.
She said there's like one vocabulary section. I'm pretty sure.
There's a fill in the blank vocabulary section with no word bank.
Right.
And then she said the rest of the vocabulary can come up like you can have like one where you have to find a solution where all the variables are like integers, or like find the
This
equation
is
of a
like-
line where you can't have rational numbers or whatever. And should use,
This
should
is like
use
if you
symbols.
don't, just if like you don't know the word, and since you don't have a number line or word bank, so you just look in like the questions, and you might find a word that you could use.
Yeah, that's true. She said that you could look throughout the test and maybe the words would help you.
And
Wait,
the
what-
only vocab is the only vocab the one in the review sheet, or is it in something like other
This is
stuff
the-
like?
I think it's
This
just
is
stuff
the
in the
review
review sheet. I think it's the
Okay.
vocab from the review sheet.
Right.
Okay.
Are
And
you
I forgot to
recording it?
mention a relation. I'm thinking that she might do this as one of vocabulary relation. Another way to think of it is just if you like connect it like this. That's a relationship between A and B. Okay. So back to this one. Okay. So if you want to do the whole base, remove this, and it would be 5 times 4.3 divided by 2. But that would be the area of this triangle, approximately. Okay. Did you guys get 10.75?
Wait, why did you
That would
divide
make
by
sense.
2?
Hmm?
Wait, why did you divide by 2?
Oh, because it's the area of the triangle is base times height divided by 2.
That's why it was multiplied by 5. You could just multiply by 2.5 and get the same answer.
Oh, so that's why
Yeah,
you use the
okay.
Pythagorean theorem. Is because okay.
Okay, hold on, Adrian.
Yep.
Let me see if this method works. Right. So, I don't know, maybe that. So, I just did the same thing that you just did, but I did it where like you know what? Never mind. I'll just do it your way.
Did you find the area of this triangle first and then multiply it by 2?
Yeah.
Yeah, that's another method that works. That's the one I was going to show,
Okay.
but it takes a little longer. Okay. So that one's done.
Yay.
Okay, and let me get
Oh,
some
also,
graph. Sorry?
Apparently, she doesn't like when she either doesn't like when we cross out work or when we erase work. I remember she was picky about that last year with
If
somebody.
you cross out work,
Yeah, she
work,
pointed it out.
put in one X. Don't scribble over it because that's bad communication.
Put what?
Like one X, or like you like cleanly cross it out. Don't scribble over your work.
Okay.
Because
Well,
also,
yeah,
like, if
I'm
some of your, because also if some of your thinking there is right, I think you can get points.
Yeah, I think she said she's gonna give partial.
Yeah, you can get partial credit if your work is right, but you don't get the actual answer.
So, Adrian, did you get 4.33 for that answer? The geometry?
That was the height. That was the height. The full area was like 10.75 or something.
Okay. And now we're going to solve 3.2. Problem 3.2. Find the distance between the points 0, 0. Let me just plot that right here. 0, 0, and 3, 4.
So the total is, oh my bad.
Okay, and like Miss Frisbee
My
said,
bad.
you can actually just draw a right triangle, and that's the same thing as the distance formula. That would be easier in this case, I believe. So let's do that. This is 3.
5, no? It's 3, 4, 5.
Yep, it's 5. So, and if you don't know the 3, 4, 5 triangle right away, you could do it like this. 3 squared plus 4 squared is equal to c squared. So 25 is equal to c squared. 25 5 is equal to c. Okay. So that one's done. And erase some of this.
She don't do curves, right?
Wait, what was the answer to that one?
Answer to this one? Distance was 5.
Yeah.
You just drew a right
Yeah.
triangle, and that's the distance. Okay.
Wait, did you do a distance formula?
He didn't. He graphed out the triangle.
Oh.
You
Or
can do
just use
distance formula,
Pythagorean's theorem.
or you can use Pythagorean. They're actually the same formula. Okay. Find distance between
Adrian.
yeah.
Do you by chance know if Frisbee's gonna do a curve?
She doesn't curve.
Oh.
She doesn't curve.
Yay!
What?
Why would she curve?
Okay.
Why wouldn't she not know?
Why would she
mean-
curve?
Doesn't she add extra credit?
No, not on the test. No, not on these. Her extra credit
Number
is
two.
from the late passes. I'm pretty sure.
This is Peggy.
Oh wait, no. The midterm and the semester exams have extra credit
Yeah.
on them. The semester
I
exams
remember-
do. A regular
I remember
unit test
Cooper
does
saying-
not.
I remember Cooper saying, "Oh yeah, I got 115 on the phone."
Yeah,
I'm like,
because
"Bro,
okay,
what?"
my bad. You're right. The semester exams are curved.
Yeah.
The semester exams are curved. The actual
You
because
should make
those
the
are
normal
IB.
curve, too.
The normal unit tests are not curved.
Alright. So continue. Show that the
Yeah.
triangle bounded by 0, 0, 0, 3, and 3, 4 is the right triangle. Okay, so this might look familiar.
So like opposite reciprocal slope something.
There is a simple way to solve this. That also
Pythagorean theorem.
Adrian,
Hmm?
could you send the document? Is it in the Telegram?
I'll send it real quick. Okay.
Because I can't really see like the small letters.
Where is it? I'll send it on, sorry. We're gonna meet the 409. There it is. Okay, that's a document.
Like,
Okay, so we're gonna use a special version of Pythagorean theorem. So the regular statement is if a triangle is right, then it satisfies a squared plus b squared equals c squared. What we're gonna do is we're gonna do the converse. You guys remember the converse from geometry?
nope.
It's the statement reversed. If the triangle is a squared plus b squared equals c squared, then it's right.
So that's what we're gonna do. If it satisfies a squared plus b squared equals c squared, then the triangle is right. The converse is not always true in general, but for the Pythagorean theorem, the converse is true. So that's what we're gonna do. If it satisfies a squared plus b equals c squared, then it is the right triangle. Okay, so we have 3, 4, 5. 3 squared plus 4 squared equals 5 squared. So it is a right triangle. Does that make sense?
Yeah.
Okay. Or if you want to do Maya's method, you would just show that.
That's too complicated. It took too long always.
Or you could take the simple method that the x and the y axes are always perpendicular. So
Yeah.
it has to be a right triangle like that. Okay. So that one's done. 3.3. Okay. Where's this a little more? Okay, the line segment AC lies on 2, 1 and 10, 1. Point B bisects segment AC, creating a midpoint. Find the length of AB. Okay, so let's just graph those. 2, 1 and 10, 1. 2, 1, 10, 1. Do you guys know what a bisection is?
You cut it in half.
Yeah,
No.
you just cut it in half. So if you want to cut it in half, you're going to take the average of these two. So 2 plus 10 divided by 2, 6. Did someone whisper Cooper? Oh, was that just me? Okay.
Cooper joined and left.
Okay. Okay. So we have A, B, C, and we have to find the length of AB. How do you find the length of AB?
Either distance formula or you could count it in this case.
Yeah, so it's just 4. So the answer to
This one happens to be on a line, and it's not on a diagonal.
So the answer to this one is just 4. If you have midpoints, what you're gonna do is take the average of the x's, take the average of the y's. Like if you have 2.
Wait.
Hmm?
Am I dumb? But you're saying AC lies on A 21 and B 10-1, and if point
I think
B
it's
Oh, you're right.
bisects it, wouldn't be double?
You're right. You caught that. That's a good typo. Okay. That was a good catch. This is supposed to say C. Okay. Thank you, Maya. So now moving on to inverses. Okay. Find inverse f of 10 if f of x is equal to 5x plus 5. Okay, and there's 2 minutes to do this, so we're going to do the straightforward one first. So we're going to find the inverse of f of x. So f of x is y. So y is equal to 5x plus 5. So what do we do to find the inverse?
switch x and y.
So
Subtract 5 on both sides. Maybe.
yeah, we're gonna do that. We're
Do
gonna
you
do that
need
after.
to?
Wait, never mind.
Do we need to find the inverse?
In this case,
Oh yeah, no, never mind. I'm dumb. It would be too hard to never mind.
you could, if you really want to, use like speedy. Okay, so x is equal to 5y plus 5, and like Yannick said, we're gonna subtract 5 from both sides. X minus 5 is equal to 5y. Divide both sides by 5. X minus 5 divided by 5. Or, like I heard someone say, you could divide each one by 5. That also works. So x divided by 5 minus 1 is equal to y. And now that you find the inverse, don't forget to switch this back. This is going to be x divided by 5 minus 1 is equal to the inverse of f. Okay.
AJ, can you zoom out to like when you started it? Okay. Let's see. You can look at it. I should.
Okay. So now we have x divided by 5 minus 1 is equal to this. We can plug in 10. Okay. So we got 10 divided by 5 minus 1 is equal to this.
7.
Yep.
I'm just kidding.
Uh-huh.
So, wait, is
1.
it 7 or is it 4 or is it 3? Could someone tell me?
1.
It's 1.
It's
I thought it
yeah.
was 1.
It's 1.
It's 10.
It's 1.
Oh yeah, there's 10.
Order of operations.
It's 10.
Guys, we have to use the base system.
Bro, I don't know how. I got 20, bro.
Bruh.
What? 20?
Bruh.
Bruh.
I see what he asked for a curve now.
No, answer the bro.
Alright, bro. Alright, bro. It's a joke.
Alright.
I know.
Find the inverse of y is equal to x squared plus 5. Okay, so
Wait, so wouldn't that be that was the question. Hold on. What's the name for it? What's one of the vocab words? See, this is why I can't remember vocab. It's not a function, it's a
Relation.
A relation.
relation.
Yep.
Yeah, wouldn't it be a relation?
Mhm.
But does she want us to put write it as a relation or just write it as the square root version of it?
I would assume she just wants to as a square root version, like square root of x minus 5, I'm guessing.
Yeah, probably.
Okay.
You should.
Question.
Hey, Adrian, I think to demonstrate my skills, I think you should let me do the inverse of that.
Alright.
No.
So we got
Alright, so
let's start from the beginning.
we start off. So we swap out x and y,
Yep.
So then you get x equals y squared plus 5.
Mhm.
Yeah, and then since you're trying to solve for y, you switch them again. So then you get y squared equals x plus 5.
Yeah.
Oh, I'm sorry, x minus 5.
Mhm.
And then you square root both sides.
Square root both sides.
Yeah. You get y equals plus or minus.
Okay, so this is where it gets technical.
Yeah, because that would be the relation.
It's the
Let me
principal
graph.
root.
Let me graph this real quick.
Minus 5.
Okay, so Yannick is right. If we want to take a case, let's graph both of this. X minus 5, his process is right. So this is what it should look like, the inverse. If you want to take the pure inverse, where you have the plus or minus, you would get this. F of y is x. Hold on. There we go.
Whoa.
If you want like a pure graphical inverse, you would include the plus or minus. But in this case, since we're dealing with square roots, we don't want this lower
Just the
branch.
principal root.
Yeah.
Okay.
Because inputting any of those negative numbers would give you an imaginary solution.
So this is
Gotcha.
what you would want. Okay, so yeah, Yannick's process is right here. Let's put a smiley face.
Yay!
But good job though. Okay.
What's the answer?
The square
Y
root.
Square root
equals
of
the square
x
root
minus 5.
of x minus 5.
So
Alright.
the leftmost
You-
point.
If you put plus or minus, will it be counted as wrong?
Probably.
If she wants to put
I
like
would
the
think. I would think so.
principal, right?
Yeah, I think she wants
The
the
principal
principal
square
root.
root.
Then leftmost point. It was we saw it a few seconds ago. Okay. Is the
I would
inverse?
just do what she expects you to do.
Yeah.
So does the inverse
I don't
of
think
sine
she's
of x
expecting.
represent a function? Why or why not? Okay, so let's figure this out.
Yes.
And why would it represent a function, the inverse?
Because isn't the inverse No, am I wrong? I don't know what.
It would. It fails the horizontal. Wait, does it?
No, it doesn't.
Uh-huh.
No, it doesn't.
So
Does it?
let's check it out.
Oh
Wait.
wait. No. Yes, it fails it. I think.
It
No,
fails it, so it wouldn't be. It fails the horizontal line test, so it would not be a function.
So
Wait.
let's just
I
No,
forgot
it
it was
doesn't.
inverse and not like reflection.
No, it does. Wait. I think it does. I think it is a function.
It fails the test.
It fails horizontal line. That's
yeah, as we see here, if you draw the horizontal line test through entire of a function, it fails it every single time. So that means the inverse is not a function. And if you're curious, this is what inverse looks like. Arc sine of x. So the reason it gets shrunk so much is because it's the inverse and we want to keep it a function. Or else if you plug in like a number, you wouldn't know what to get. So they have to shrink it. Okay.
oh. So that's only showing you the section that is a function.
Let me see if I can get it to show the real stuff. F of x is this. F of y. Inverse is
Oh, okay. Yeah, that fails the vertical line test like
So
everywhere.
the inverse of sine. Whoa.
okay. So yeah, this is what the inverse of sine of x would look like if you want it to be graphical. Does this fail the vertical line test?
In every possible point, yeah.
Yep. Okay, so it is not an inverse. Sorry, it is not a function. I mean, okay.
How do you graph, if she just gives us graph sine of x, how we would just graph like a waving line?
Probably a graphic
She wouldn't ask you to. She would either give you a graphing calculator, or she wouldn't ask you that right now because we haven't done the trig functions.
If you do want to graph
Yeah.
it, what you gotta know is that sine of x oscillates between -1 and 0. So -1 and 1.
The what?
It's gonna keep like bouncing between these 2 points. But
Okay.
-1. And 1. That was a bad drawing.
Oh, I got you.
Okay. Okay, now on to compositions.
Moving on to compositions.
Ooh,
Two.
we got fog and hog.
Wait,
Never
Adrian. So like for the inverse of the sine of x, wait, I thought it was like horizontal. Don't you use like the horizontal line test for inverses?
We did.
Yeah, we did the horizontal
y'all
line
did?
test, and we see that it's not a function. We draw a line.
Oh, so that's the inverse. So like,
That the
like
inverse is not.
No, you use the horizontal line test on the original, but then that would mean that it fails the vertical line test when it's inverted.
so would that work for any other functions? Like if you graph them, like if the original fails the horizontal line test, that means
That means the inverse
Yep.
is not a function.
the inverse would not be a function. Oh, all right. It's like if I had a parabola, a horizontal line test on it, I mean, it would fail it. So that means there's an inverse.
Yeah,
not
you'd have a hyperbola that opens sideways.
I
not
know. So
hyperbola.
it wouldn't be a function.
Yeah,
The inverse would be a
is not
relation.
function.
Huh?
Yeah, the inverse of this is not a function unless you restricted the
Okay. All right. Yeah, I was just wondering.
Okay, so now onto composition of functions. That f of x.
Hey, Adrian.
Yeah.
One last question about the inverse thing. So let's say vertical is like the one that goes straight up and down, right? So when we like when she says like the vertical line test, that's to like to show if that a function is a function, right?
Yeah.
Okay. So then the horizontal line test, what does that do again? Is that just for
It's
inverses?
if the inverse is a function.
If the inverse is a function, okay. And to find the inverse, you just like to swap the x and y and stuff, right? All right, perfect. Thank you.
Okay. Okay. Now for section 5. Let f of x equal to x plus 3 and g of x is equal to x squared. Minus 1. Compute the composition and simplify. Do you guys know how to use this little circle notation?
Yeah.
Yeah, I think she went over
I don't know how to type
F of
it,
G.
but
It's f of g of
F
x.
of G of
Yeah.
X. Yeah.
So you just ignore it and put parentheses around it if you know how to deal with it. F of
Yeah,
G
it just saves you from writing all the parentheses when you have multiple
Okay.
things.
So we're gonna have
so like if it's G and G O F, that would be G of f of x, right?
Yeah.
okay. So we're gonna
So
have
x squared plus 1.
f of x squared minus 1.
Which is
Okay, and what is f? F is 2x plus 3. So let's just plug that in. Everywhere there's an x, we're going to put x squared minus 1. So 2 of x squared minus 1 plus 3. Okay, this is 2x squared minus 2 plus 3. This is just 2x squared plus 1. Okay, so that's the composition. Okay, and now for the next one. Given h of x is the square root of x plus 2, and k of x equals 3x minus 4, find the composition h of k of x and simplify the result. Okay, let's erase this. Okay, let's just pretend
Are
we
you
have a
recording the
circle
session?
This is getting recorded right now.
Okay.
Okay, so this is h of k of x. Okay, what is k of x? K of x is 3 minus 4. X minus 4 into h. And h is this. So everywhere we see an x, we're going to replace it with 3x minus 4. 3x minus 4 plus 2. Okay, so that's 3x minus 4 plus 2. So that's just square root of 3x.
Plus 2.
2.
Minus 2.
Okay.
Wait, no, it would be minus 2.
Whoa, whoa, whoa.
No, you're right. You're right, it is minus 2.
Yeah. Hold
Oh,
up.
that was just a little silly.
She wouldn't make us do f of g of k. I mean, I don't know.
I mean,
if it's like
we're not bad.
on the notes, because like there's like what like
Yeah, there's one of the
three
practice
functions.
questions. One of the practice questions has it like that, where there's no numbers, and you have to just simplify with the variables.
Oh, okay.
Also, she said IB exams you don't have to simplify. You don't have to simplify unless it calculates out to an integer.
And here it says simplify.
Let me look.
Simplify.
Let me look at the look. Actually, let me check the mark scheme. She said specifically when you have to simplify.
So when the example if the h comes first, then the k will be the thing that goes into the x, and if the k was first, then the h is the thing that goes into x.
Yes.
Or
Just the closest one.
Okay.
Closest one gets distributed first.
Okay.
And this is a bonus question.
And what if there's more than one?
If it's like a h of
Closest one.
g of a or like of b, you mean?
Yeah, like what if, because she was talking about that in class, like what if we have something like that?
Okay, if it's a gobe, we're just gonna do g of b first, g of b of x first, and we put the result of this into h. We go in order.
Okay.
A gobe. Okay.
There's one. I'm sending you the simplification things that she said.
Okay. Bonus question for this one. Since we have a square root, what is the domain over a composition?
For the composition?
Wait, what
Has
did
to
you say?
be greater than or equal to -2.
-2 or 3?
What was the question?
What is the domain of? Just go back a step.
What's the domain of that and 1? Yeah.
What's the domain of this?
The domain of that?
Domain, is it anything bigger than -2 over 3?
Okay.
No.
So we have to.
How do we find it?
We're plugging in 3x minus 4, and we want this to be greater than or equal to -2. 3x minus 4 is greater than or equal to -2. Reason being, if we plug in like 0 for this, plug in 0 for x, we're going to get the square root of -2, which is bad. That gets a sad face from me. This is bad.
Oh, so it'd be like 2/3.
2/3? Oh, I haven't done it in my head, so let's see. 3x.
Yeah.
Because it can't be negative, right? I vaguely remember. It's like you have to be the values for which like
You mean-
it's not negative.
You mean 2? Wouldn't it be 2? Like, when you add 4 to both sides, you get 2.
Oh, yeah, you're right. Is equal to 2. So that means x is
And 2/3.
2/3. So yeah, John Isaac was right.
I was at 2/3.
Oh,
okay. That was very
I
fast.
thought it was.
Okay. That would be the domain.
Okay, I'm very confused on how you got domain, bro.
So that's how you determine domain.
That's how you determine domain.
She said this was 18 question, right?
You got the Adrian. I'm not answering that.
All right.
AJ.
Yeah.
So on the test, when she tells us to like define the domain of that, so do we just like will it be of like the thing that's getting inputted into the other function,
Okay, let me.
and then use the
I'm gonna write this another way.
Isn't it just like anything that's in like the square root?
This might make more
Because
sense.
usually.
Let's call this y, this chunk. Or sorry, let's call it a for Adrian. A plus 2. Okay, what's the domain of this function, Yagnik?
It's a good question. Hold on.
So it can't be negative.
What is it?
So it can't be negative. That's the biggest clue.
Yeah, it's for me like +2, right? Like above +2.
So we don't want it to be negative. So we're gonna do a plus 2 has to be greater than or equal to 0.
0, yeah.
Okay, so that means
We do that method. Okay.
must be greater than or equal to -2. But what is a? A is 3x minus 4. So that means 3x minus 4 is greater than or equal to -2. And then you get the same answer. X is greater than or equal to 2/3.
Where'd the 4 go? Oh, you added it to the other side. Okay.
Does that make more sense?
Yeah. Okay, so. Okay. So we just kind of have to. So the greater to sign is always going to be greater to the other side, right? Not greater to 0.
Yeah, because we want it to be bigger than 0 or equal to it.
Okay, and then like if we have like negative a or negative x, then we have to divide it, and then that would switch the signs over, right?
Yes.
Okay.
Okay, now to reflections. This one's going to be short and sweet, just like Mr. Enrico's wife.
Oh my god.
She's 4'11".
Oh no.
Absolutely.
No, she's 4'11 on a good day and 4'10 on a bad day.
What?
Oh, he had to specify.
What is it?
Specify.
He specified that this is new. We didn't hear about this one.
He's evolving.
We just heard right there. He said right there SAQ short and sweet.
I know he's still putting money in that trust fund.
Okay. So now to reflections. Did I announce that? Yep. We got 2 more
Oh my
left,
gosh,
right?
I hate reflections.
Okay. So reflect the point 9, 10 across the x-axis. Let's draw the point real quick. 9, 10. We just eyeball it. Okay. And we want to make this into a mirror. This line is a mirror. If it was a mirror, it would be around here, right?
Yeah. So you just invert y.
9, 10. So you set the 10, instead of rising 10, it's sunk 10. So it would be 9, -10. That's the answer.
Also on the test, make sure you label your axis. If you don't label your axis, that's points off.
Oh, right.
Adrian, wouldn't it not? So why wouldn't it not be -9, -10?
Because -9, -10, it would be like right here.
That's a rotation. That's a rotation of 180
Ooh,
degrees
oh,
instead of
okay,
reflecting
I
it.
got you.
Are we supposed to have a scale?
A scale?
Yeah.
That's what I'm saying. Come on, Adrian. You gotta scale the axis, man.
I think she said
think
she took a point
You're
off or something.
confusing
Like
us.
It's not the fact that she's taking points off. It's just poor mathematical communication.
All right.
I think
if
aren't
you
they gonna
guys-
mark
I mean,
that often? Like,
if
so
she's
Yeah,
not
you
gonna take
have to
points
have-
off, then like
You have to have every line, and you have to divide it by 0.5 just to be more accurate. Even though you don't need it right now.
if you guys want
No, but you don't want your scale to be too small because then it's hard for her to read, and then that's also points off.
didn't they say also
No.
like on IB? Didn't you say on like IB tests they're gonna count the scale and stuff? Just like
Yeah, but she said you can space out your scale by like 5 at the most. You just have to have a scale.
Okay,
Yeah.
guys, if you want the scale, there's your scale.
Thank you. Now it looks right.
So now for this one.
And
So this here. So- Okay.
Guys, what was the general question? What was the question? I didn't see it.
It was just
it was
9,
it
10 across
was
the
from 9.
x-axis.
Oh, okay.
Okay, so notice here that 9, 10 is the same distance to here than from here. These are both distances of 10, right? We're gonna need that for the next problem. I haven't seen like the tests because, well, I don't write the tests. But I have a feeling there might be a curveball question like this. Reflect the point 9, 10 across the line x equals 1. We go into the
Oh, and you need the distance from x equals 1.
Yeah.
Hmm.
So it would be -7.
Okay. So let's draw 9, 10. Yeah, what's the distance to
Gonna be
here?
Oh
9.
no. Wait, no, I was looking at the
Yep, it would be 9.
-8.
And if we want to reflect it, it would also be the distance from 9.
So -8. Yep.
Okay, so 9, comma, -8.
I feel like that is a question she could put on there very well.
What?
The distance reflection we just went over.
Okay, so it's like how many points is from that line, and then go down that many points.
Mm-hmm. And the same thing if it's left or right.
What?
Like if it's
Like horizontal, yeah, okay, yeah, I got
you
you.
just do the same idea. Okay.
If it's horizontal, then you go the points across.
Okay, now
Alright.
to section 7, which is also short and sweet, like Mr. Enriquez's wife.
That joke is never dying, is it?
Adrian, what about your wife?
He always says that, it's stuck in my head. Applying. Okay. Applying function transformations. Translate x squared 1 unit to the right. Okay. How do we move this 1 unit to the right?
X minus 1 squared.
If k is less than 0.
Okay, we got our first step done. Then apply vertical dilation of factor 2. How do we do that?
You just
Vertical
do
dilation.
multiply the whole thing by 2.
Multiply by 2. Thirdly, reflect it across the x-axis. How do we do that?
Put a negative in front of it. Put a negative in front of the 2.
-2.
Okay. And
-3.
Yep, -3 translated down. So -3. Okay, you guys got that pretty quickly.
Wait, I have a question.
Yeah.
It's like for vertical dilation, like how do you determine if it's like a stretch or if it's compression? Because I've had trouble figuring this out.
If it's negative or positive, right?
Okay. So
No, based on your dilation factor.
Like greater than 0 and one's 0 less than is in between 0 and 1.
So if
The
it's
stretch is
if it's 0.5, is it getting? Let me get a slider here. A is equal to 0 and 1. Okay. Observe the animation, John Isaac. When it's between 0 and 1, is it getting bigger or smaller?
Between 0 and 1, it's getting larger.
It's getting larger. So
So
what
it's
would
a
you say
stretch.
that is?
Huh? So this is a vertical stretch?
Vertical compression.
Vertical. Wait, hold up. Let me see.
it's getting longer, but it's getting shorter. If that makes sense.
Watch this. This is what a compression looks like. We're gonna squish the y-axis. Does that make sense?
Wait, so it's a compression. So it's a compression if it gets larger. It's a stretch if it gets smaller.
Let's see a stretch.
For vertical, yeah.
Yeah, for vertical, it's getting a lot skinnier if we stretch it.
So it would be a stretch if it's like 0 less than k less than 1. something
So,
like that.
so if the factor is greater than 1, it's going to be a stretch like this. If it's less than 1, it's going to be this. It's going to be a compression.
So yeah, if you like stretch it across, like if you think about like holding a rubber band in vertically, like one hand at the top, one hand at the bottom, you stretch it and it becomes skinnier, and you compress it, it becomes like more less skinny, I guess.
It becomes skinnier sideways.
Okay. And now that we understand...
That's what I'm. Never mind.
How about for horizontal dilations?
Horizontal dilations. Go ahead.
Okay, horizontal dilations. So dilation is a vague term. It could mean getting bigger or smaller. Could you specify?
It's like milk. It's like determining if it's like stretch or compression.
Okay, horizontal stretch, it would be like this. What does that look like?
It's getting wider.
It's getting wider. Now let's see horizontal compression.
Smaller. So like, what would the K? I just want to know what the K value would equal. Because I know I just have the notes. Because it's just like.
Okay. So let's cover that real quick. Okay. So when we say vertical dilation by a factor of 1, so by 2, we multiply the graph by 2, right?
Mm-hmm.
If we do horizontal dilation by a factor of 2, what we're gonna do, well, no, that's not right, because if we do
Be 1
by
over 2, right? Or be 1/2.
we take
because
1
it's
over
usually.
k.
Yeah.
So it's by 1 over 2. So it's a horizontal dilation. We take like 1/2 of this, and that's what we multiply it by. We take.
But it's not always the same as. It's not always the same thing, is it?
So
like a horizontal dilation by a factor of 1/2 is not always the same as a vertical dilation by a factor of 2, is it?
Let's see. So, where's like vertical dilation of 1/2, you said?
I'm saying maybe not for quadratics. Like, if it's not like a horizontal dilation by a factor of 1/2 might not always be the same as a vertical dilation by a factor of 2.
So let's test theory. Let's get some super complicated function. Sine x4 plus cot of x. Actually, we don't have a way to check that, but that's a good point. Okay, sorry about that. Moving on. Given the square root of x, what transformations do we use to obtain -6 times the square root of x minus 6 plus 7? Okay, so let's just go in from the beginning here. So what does x minus 6 mean?
It's x, and then it's shifted 6 units to the right. Right? Yeah.
Wait, Adrian.
Yeah.
You said it was the same or it wasn't the same?
For quadratics, it is the same.
For quadratics, but for other functions, is it always the same or no?
I'm trying to think of a counterexample. If not,
because I think she said something about it not being the same.
yeah, it's not the same.
But
That's good. Okay. Yes, this is 6 to the right. 6 to the right for our first step. Okay, and what about this -6? What does that mean?
reflection.
Yep, so that's a reflection because of the negative. And what else?
Vertical stretch by a factor of 6.
Okay. I would say vertical dilation by a factor of 6. Dilation. Somebody write all that by 6. Yeah, you guys know what that means. Okay. And what about the 7? What does plus 7 mean in this context?
Translation upwards.
Yep. So up 7. Nice. Okay, now for domain and range. Someone's reacting to my messages. Moving on to domain and range. Okay. And for the last question, I'm not sure why it's not displaying here. There was an x squared minus 9 term, or x squared minus 9 part. It just disappeared here. I'll try that in later. Make some corrections here. Okay. So now write the domain and range of y equals x plus 1 in 2 different ways. Okay, so firstly, what is the domain of y equals x plus 1? What numbers can you plug into this?
All reals.
Yep. So how do we write that?
Negative,
What's one?
parenthesis, negative infinity, comma, infinity, and then
Okay.
close parentheses.
Okay, and do you guys know how this notation works, right?
Yeah.
Okay. Just like last number, first number. Okay. And now for the next one. We're going to use set builder.
Yeah.
The hardest part about set builder is drawing the braces, surprisingly. Okay.
I still can't draw the braces right. That's why I use interval.
Alright.
X.
Okay, so I have x.
Wait, she's gonna take points off if you don't write it.
Such
Fletcher?
that
Maybe. Okay. Such that x is what?
Set of x. X is an element.
set of all real numbers.
Yep.
Is an element of all real numbers.
Hooray.
Okay.
Yeah,
we
this
have
is
domain.
the notation you use the most.
Yep, set builder. Okay, now for the range. What numbers can you get out of y equals x plus 1?
Any, because
yeah.
if you have all real numbers as your domain,
Your
then you can have all real numbers as your range.
mean,
In this case,
So what's the interval notation for the range?
the same as the
So-
domain.
Yep, set domain. What about set builder? Is it the same?
It would be the same, but you'd switch the x for y.
Wait, y such that y is a member of R, or real numbers. Very nice. Let me draw something real quick here. Oh no.
I haven't seen Inkscape in so long.
I guess I'll just type it in here manually. Since you got
This notation this is bad notation. Just kidding. It's fine.
Alright, find the domain of the function, the square root of x minus 10. Okay, what numbers can we not plug into the square root of x?
Anything less than 10.
Yep, so... x? Oh no. Because I'll just keep like that, this one. X times 10 is greater than or equal to 0. Because we don't want negative numbers. Okay, so that means x is greater than or equal to 10. That's your domain. Okay, now for the next one. Find the domain of the function 1 over x squared minus 9. Okay, what would make this undefined? What would turn this into a bad
Set x squared minus 9 to 0.
X squared minus 9 equals 0. Oh no, a scary quadratic. Are we going to use the quadratic formula for this one?
No.
Why?
Yes.
You
Okay,
can do
yes.
x squared. Oh boy.
We
Did think it was
quadratic
Dion.
or what?
It was Dion who said use quadratic.
Alright, then we can use quadratic if we have to. Alright, so negative b plus or minus
Plus or minus the square root
Well, let me move this.
We don't have room. Yeah.
Absolute value of x can't be 3 now. Would she accept that? Like, say absolute value of x cannot be 3?
That would be a really weird way of saying it, but that's right.
Adrian.
British.
For
I
the
think she
way,
gets really
like,
annoyed with my notation.
Hmm?
She gets really annoyed
Oh,
with my
wait.
notation.
Yeah? Who's talking?
a way to find the domain of like the problem 8.2, could you do like the thing you showed me earlier where you do x subtract by 10 to the inequality of like the greater than or less than of 0?
That's what we did. Yeah.
Okay.
Okay,
If
so
you were paying attention, you would know that.
Nah, but I'm
Well,
trying to do it by myself and then look at it.
Okay.
independent learner. Okay, as someone said, we're gonna use the quadratic formula for this problem. Okay, so x squared plus 0x equals 0. I didn't know you guys were sadists, by the way. Okay, so we have negative 0
It was Dion.
plus or minus 0 minus 4 times 9 divided by 2. Let's make sure we can do here. Times negative 9. Okay, so we're gonna have 0 plus or minus. Okay, 0 becomes irrelevant. So it's just plus or minus the square root of 36 divided by 2.
Over 2. So it's negative 3 and 3.
So plus or minus 3. Okay, so that means x cannot be equal to negative 3 or 3. If you want that
Adrian, without doing all the quadratic equation stuff, can't you just look and see and just factor out x squared minus 8 equals 0, and then get x subtract by 3 and then x plus 3?
Yeah, I was just doing because
She
someone
might,
suggested it.
Okay.
Someone said it's a quadratic formula.
and she might also give us.
No.
She might give us one where it's like harder to figure it out without the quadratic formula.
Mm.
I feel like if she were to do that, she'd put it on the calc section, though. I don't think she's gonna give you something crazy on the no calculator section.
That's
Okay.
fair.
If you write this in set builder, x such that x is a real number,
Oh, there's your x squared minus 9.
and x cannot be equal to negative 3 or 3. Okay, and that concludes the problems. Any questions? Any last concerns, questions, problems?
Nope.
What's 1 plus 1, bro?
Cries of tears.
I lost on that.
1 plus 1?
Yeah.
Well, it really depends on our base again. It really depends.
Bro, I'm not trying to have you do base again, bro. That was sick.
do it in base. Well, actually,
Base of 11.
I mean, whatever base you do it in, wouldn't it still be 1? Because it's or wait, no. Oh, well, actually, no, because it'd have to be 0, or it would have to be.
You could do it in base pi if you wanted.
Oh boy, here we go.
Alright, so 2 is equal to pi to the x.
What is this?
Wait, what's happening right now? What's this?
He's doing 1 base pi plus 1 base pi
All right.
That'd be-
because Yagnik said, "Yo, what's 1 plus 1?"
The last time I did it, he went on some ramble about
Oh,
bases.
you
and then I got
change a
lost.
base formula.
Change it x.
Change a base formula.
I didn't remember.
Ooh.
Oh wait, is it the other way?
That's
Yeah, right.
crazy.
Change that so quick.
That's crazy. The common log of pi over, or the common log of 2 over the common log of pi.
Okay, so this is what it's equal to in base pi.
Then, so,
Alright. That concludes today's review.
Thank you.
Adrian, you
Alright,
should
Okay,
spell
so
it.
on some real stuff, the principal square root, is that just the square root of anything?
The non-negative
it's
one.
the non-negative square root,
non-negative.
and that's what Miss Frisbee prefers.
Yeah, the
Like-
non-negative.
Like, what's an example?
Like okay, like the one that Adrian gave us, like the x squared minus 9 equals 0. Like x could either be 3 or negative 3.
Oh, okay. So
So you'd only use 3.
But when you're solving that in an equation, it could be if you have like the square root of x as a function.
Or like the ones he wrote on there. X squared equals 100.
If you were to square root that,
Either 10 or negative 10.
yeah.
But if you're using this notation, the square notation, then it's just this one.
What are we doing now?
Oh, they asked about the principal.
Yeah, I got asked about the principal root.
Alright, so that ends today's meeting. I'll end it now.
All right, thank you, Adrian. You to go.
Thank you, Adrian.
You're welcome.
thank you.
Oh, Adrian.
Yeah. Yes.
Adrian.
Yes.
I had a quick question. What resources do you use to learn calc? Because I don't know like what to do.
All right.
I wanted to just learn a little bit of it on the side, but I don't know like what resources I should go to.
Okay, I'll write some here. Khan Academy, definitely. There's
Obviously.
Calculus for Dummies. This is what I use to learn it in 7th.
Oh, I have that book.
Okay, yeah, this book is really good for learning the basics. These other YouTubers, 3 Blue, 1 Brown. Have you seen this series?
No.
Okay, so watch this definitely if you want to learn calculus. He wrote.
Isn't there also?
Yeah, that's the calculus.
Honestly, the book that Frizzy gave us for pre-calc, it confuses me greatly because I've tried using
Look
the
up Bob,
book
bro.
Frizzy gave us, and like I got lost because there's like too many words.
Look at Bob.
There's also black pen, red pen, but that's not really basics. It's just a dude doing a bunch of crazy things.
Yeah, this guy solves problems really quickly on a whiteboard with a black pen and a red pen, as you can guess. See, I would take a picture of this real quick if you want to learn calculus. These are the best resources. And if you want to find...
Okay, thank you. I'll take a picture.
How hard would it be to
might
start?
cover everything.
How hard would it be to start learning at this point with what we know?
Learning? With what you know, okay.
Oh, y'all.
Adrian, when did you start learning?
I learned calculus in 7th grade. And
Yeah.
using
Crazy.
this book.
I tried learning calculus in 5th grade. It did not go well.
Yeah.
This isn't even on my mind, bro.
Today.
Last through pre-calc.
No,
Forgetting the
I
kind.
heard.
Fifth grade.
I heard
mom
this
forgot the
kid-
concept of integration.
But my cousin
I heard
from
this
India,
kid
he said-
learned.
Like kid.
I heard this kid learn calculus when he was in like 4th grade or something, and I wanted to one up him,
Yeah.
and then I got like so mad at myself that I just gave up.
5th grade Maya forgot the concept of integration.
Exactly.
Such a shame.
Bro, my
Alright, guys.
cousin he's like 6. He's in the 6th grade, and they're like, yeah, I learned calculus last year. I'm like, bro, what do you mean?
I
bro?
mean, that makes sense because like in other countries, I remember like Steven, because like they made, like he said, like
Well, he
China,
was
they
built
made him
different,
like
bro.
learn like math. Like he was like in freshman year, he was already like way ahead of us, and he already knew like calculus and stuff.
Yeah.
Right, Navin?
Where'd he go?
I think so.
My
He went to a
he's,
private school. All right, guys, it's time to start reviewing for Chem.
All right.
Oh,
You haven't started?
Yeah, nope, I have not.
Right, Maya.
Oh, I emailed Miss Slowacki, and she said like, oh, well, she hasn't responded, but I emailed her for practice problems because I don't know what to do.
I think Khan Academy, you can go to Unit 4, and that has like the ionics and the Stoic.
What do you
I
guys
don't remember.
from last year?
I think the Chapter 1 stuff is between AP Units 1 and 4. But the
Is
only
the
one
test
that
y'all
I
have
need
is just a
it's not review.
test y'all have
No,
is
it's
just,
not. It's not review. It's mostly review, but it's also like in AP
new
format.
stuff? Okay.
There isn't much.
What was I gonna
stuff.
say? You guys in the A-Fish notes yet? Bro, those
Yes.
11 pages?
It's not 11 pages. It's not that bad. Half of it is pictures.
Bro, now you're
Still
gonna
bad.
shut me down, bro.
Alright, Maya. So if you want to learn the intuition for calculus, which I would say is the hardest part, like once you get the idea of tangent lines, secant lines, infinitesimality, once you get those ideas, applying just derivative rules is very easy. So what I would do first is watch this video series called The Essence of Calculus.
Would it be better to learn
Okay.
trig first? Then
Learning trig, okay.
would it be better because if you like, I barely understand trig as is, and you said tangent, secant, and
Okay.
cotangent. So
In the
Is
concepts
John
of
Isaac still here?
calculus, secant lines and tangent lines mean something else.
oh,
So
Yeah, because tangent lines, yeah, it has to do with relations. Well, okay,
like this is a secant line.
relationships.
It just passes through two
Yeah, and
points.
oh yeah, okay.
Okay, let's post that real quick.
Who else is in this call?
Yeah, like no, this is a tangent line. It rides the function.
Romano.
yeah, it only
Yeah.
for like circles and stuff.
And a secant line is when you just cross 2 points. Like so. So it's not actual trig, it's just vocabulary.
Hey, Jim. For the pre-calc thing, if we have like if we're trying to find like inverse of a function, right? And or inverse of a function, and if you're trying to determine if that is function, if it's like a circle, right? That wouldn't be a function, right? Because of it fails the horizontal and vertical line test.
Yeah, so as per circle, neither the inverse nor the circle is a function.
Okay. And then so a circle won't count, a parabola will count. Okay. And do you guys remember that one thing that it was like all the graphs that we'll learn?
That table?
Yeah, it was like I printed out a paper of it. I don't know my email.
Yeah,
Guys, I need a hero. All my hard carries are in this call. I need a hero.
For what?
No, it's just like I sent it in the chat thing.
Dude, nah, but
Because I've had
you mean y equals f of x?
yeah.
Adrian, you got that.
Are we? Wait, John. Why are we going in Gen 2?
Oh, never mind because I was gonna ask you about that, but like
Oh, okay.
all my hard carries.
She just writes it. She just writes it in that way.
So it's just basically y equals x. Like y equals f of x is just the same thing as y equals x.
No. So y.
No, f of x and y are the same.
Yeah.
Huh?
So you'd be saying y is equal to y if y equals f of x.
So y is equal to y.
Yeah, because f of x is y. They're the same thing.
Oh, okay, I knew that, but that's really how you'd write it? Just y equals what? I don't get it.
Like okay, and what it could also mean is if you have y equals f of x, she wants you to put in f of x or whatever it is. Like, is this what you mean?
Oh, like if okay.
2x, and then you just
No, man, are you typing?
Yeah.
I am. Oh, here. I'll mute my
Could
bad.
you-
Just write
Yeah, I got you.
equals 2
Sorry.
x.
Yeah, and then she wants you to apply the transformation to this. So like if it's vertical dimension by 2 or x, multiply this f of x thing. That's what she needs.
What? Can you repeat that? Sorry.
So f of x, this just means like a right side. If she wants you to multiply this by k, it would just be 2kx. Does that make sense?
Wait.
Adrian,
Yeah.
if I'm trying to send a photo in your group chat, apparently I can't, so I'm just gonna send you a screenshot.
Just DM it.
Do we need to know all that?
I would know all of these except the last one. The last one you don't have to know.
Reciprocal square function.
Okay,
Reciprocal
so
square.
Y
Which
over
actually-
X squared.
It makes sense. The reciprocal square makes sense because you can have negatives when you square.
Alright. But why do you have everything off in your group chat, bro?
Because spam and because some people abuse it.
That's true.
Okay.
Because keep in mind there are like literal not there are like infants in this group chat. Not infants, but
To
they're like
establish martial law.
they're not even in there are kids who aren't even there are kids who aren't even in high school in this group chat. They're not even out the womb yet, bro. They haven't made it to that stage of life.
Infants is crazy, bro.
Yeah.
It's
Well,
to
they have
establish martial
them.
law, you know?
Yeah.
Nah, but who are these people? Like Ramana Raj,
No, yeah, he's a
they're-
freshman.
Rako.
They're freshmen and kids who are who
And
Adrian
I know,
is tutoring.
Liam Maloney, he's like a freshman or something like that.
Yeah, I think Adrian, do you do individual tutoring sessions with them, right?
Yeah, I do chess tutoring as well.
How much
Oh,
do you get paid?
do you do it here or do you do that through DMs?
I do it in DMs and here sometimes.
Oh,
How
actually,
much do you get paid?
how much?
I do it for community service.
Oh, you do the chess for community. Who gives you the hours for that?
So I'm the coach for Jewett and LCMA right now. I just asked the coach to sign up the hours, and they do.
Oh, that's cool. Okay,
Ooh.
you do it for LCMA. That makes sense.
Yo, Adrian.
Yeah.
If there's like, because I was planning to do something like that for my CAS project. So is that for like the math counts over there?
It's for the
chess.
Chess. Yeah.
It's for the what?
You could also help in math counts, but I wouldn't do math counts because everyone in math counts is a sweat.
Real, bro.
They all probably know more. They know more math than I do. That's for sure.
Real, bro.
We got many
That's why
Adrians.
That's why I've never touched competitive math.
No, I did it in what's it called? In 8th grade, but then every single time it would be like I would get 3rd place, and then 2 and 1 would always be like I think it was Siddharth. He always get like those. He sweats, bro.
Right, guys. So that's the end of this call. Goodbye to everybody.
All right, Navin. Hop in
Goodbye.
Gen 2.
Goodbye.
Half a Gen 2. Alright, goodbye.
Bye.
All right, I'm gonna 2. Adios.
Adios.
Good luck.